mark scheme for the first mock exam. First question. So ammonium nitrate NH4NO3 is a solid white powder at room temperature. It's a salt and can be made by reacting ammonia with suitable acid. Write a balanced chemical equation for this reaction. So you get 1 mark if you correctly write balanced chemical equation. So here you have given ammonia and you need to add suitable acid. So let's write ammonia NH3. So in ammonia, remember it's gas at room temperature and you react with suitable acid. So here you are forming nitrate. Nitrate is the conjugate base of nitric acid. So here you need to write nitric acid, HNO3. So nitric acid, it's acid, so it's obvious that it will be aqueous solution. So at the end, in the product side, we will form our ammonium nitrate, NH4NO3 salt. Yes. Please don't forget about the physical states. Ammonia is gas at room temperature. Nitric acid, aqueous solution. We are using aqueous solution. And as in the question, it says that solid white powder at room temperature is formed, or solid white powder it is. So we write S. Next question. Question number B. The formula of ammonium ion is NH4 plus. Draw a dot and crosses diagram of ammonium ion. So dot and cross. So dot and cross, you must use dots and crosses. So in order to do dot and crosses, we put nitrogen in the center. And remember, nitrogen has 5 electrons in outermost shell. So here 1 paired, 1 and 3 unpaired. And for hydrogen, so crosses, so we'll put here cross, and here cross. So 3 hydrogens, 3 electrons. Here I put hydrogen, here I put hydrogen. And next, the last hydrogen. So here I just put hydrogen. So this molecule now will bear positive charge. Okay, so draw dot and cross diagram of ammonium. So here we have 2 marks. So mostly first mark it will be given for the correct electron pairs, just covalent bonds, and for the second mark will be given to this electron pair that's same, so that comes from nitrogen atom. So this is ammonium ion, and please don't forget about charge. So ammonium ion has +1 charge. So next, state the HNH bond angle in ammonium ion. So here we have ammonium ion. We drew its dot and cross structure. So we know that ammonium structure, nitrogen is connected with 4 hydrogen atoms. So that's why the structure will be tetrahedral. Yes, tetrahedral. So because central atom forms 4 bonds with 4 different groups, so tetrahedral. In tetrahedral structure, you must know that tetrahedral structure has 109.5 degrees. 109.5 degrees. So next question. So 1 point. Next, the 4 NH bonds in each ammonium ion are all covalent, but they didn't all form in the same way. Explain the statement as full as you can. Refer to your dot and cross diagram if it's helpful. So in a dot and cross diagram, here what we see that for example this bond, and let's compare this bond. So these 3 all the same, and this is different. So we need to tell about this structure. So here the 4 NH bonds in each ammonium are covalent, but they do not all form this way. So 3 NH bonds are covalent, normal covalent, or just covalent. So electron pair is shared each atom donates 1 electron. So nitrogen donates 1 electron, hydrogen donates 1 electron, and they form electron pair which will be shared. And 1 NH bond is dative covalent bond where both electron pair comes from the same atom. So in this case, nitrogen. So lone pair of nitrogen is donated to hydrogen and forms dative covalent bond. So 2 points. Next question. The formula of ammonia is NH3. Draw a 3D structure of ammonia. So please remember, 3D structure, dot and cross are not the same. Dot and cross, so you need to use dots and crosses. In 3D structure, electron pair which is shared, we can draw it as a line. So one line shows that we have electron pair. So here nitrogen, again we need to write most electronegative element in the center, and we have lone pair on nitrogen, and here lone pair. So in the case of NH bond, they form normal covalent bond. So I can draw a line that shows that we have electron pair between hydrogen and nitrogen. And next, one hydrogen must be aligned in front of the screen. So we use shaded line, and we use dashed line that shows that this hydrogen is at the back side of your screen. So 2 points, 1 point for this correct 3D and 1 point for the lone pair, showing lone pair. And state the HNH bond angle in ammonia. So because of this lone pair occupies more space, so it pushes this hydrogen downwards, making the bond angle smaller than the normal tetrahedral structure. So in this case it will be 107 degrees. So 1 point. And the last question, ammonia is produced by process called Haber. Show the reaction for Haber process and state all the conditions. Explain the 2 conditions why it's used. So you have here 4 points. So 1 point for the reaction. Second point, giving all conditions. And number 3 is explain 1 condition. Number 4, explain the second condition. So first of all, Haber process, when nitrogen gas reacts with hydrogen gas, forms, so it's in equilibrium, forms NH3 in gaseous state. So this is all gaseous state. So please, when you write the reaction, don't forget to balance. So make sure that your reaction is balanced. So NH3, so we need to put here 2, and here we need to put 3. So 1 mark for this. Second mark, conditions. Conditions here, catalyst. we use iron catalyst. Temperature, okay, temperature, it will be 450 degrees. And pressure we use 200 atmosphere. Second mark for this, so iron 400, 450 and 200 atmosphere. And two conditions, so we have three conditions, so let me recall all three, let me explain all three conditions. So catalyst, why we use catalyst? So here number one, number two, number three. Number one, catalyst is used to speed up the reaction. So catalyst is used to speed up the reaction. So you can also write by lowering activation energy. So EA, activation energy. Second, temperature. So this reaction actually exothermic, yes. So enthalpy change is minus 92 kilojoule per mole. So actually increasing temperature, so high temperature shifts the equilibrium to the endothermic side. But using this high temperature, make sure, so 450 degrees ensures forming reasonable yield in reasonable time, at a reasonable time. Okay, that's better. Number three, so if we use more than 450, so for example 600, so reaction shifts to the left side, so make decreasing the yield. But if we use low temperatures, for example 300 degrees or 200 degrees, so although you get more product, so high yield, the reaction will be very slow. So this is optimal temperature. Pressure, so higher pressure shifts equilibrium to the right, or product side, to the right, increasing the yield of the reaction, so increasing the production of ammonia. So this was the first question.